So for batch counting, we have taken the example as shown in this slide. So we can see here that there are two conveyors. There is a conveyor on which some jobs are being counted by the count input. In our case, we will be using the same encoder pulses to simulate this count input pulses over here. So the task over here is to count number of this marbles, we can say, or this jobs, we can say. The count value of jobs which fit into one box is 5. So when 5 number of jobs are counted, it means the box will get full. Okay, so there should be an output generated by the counter, okay, that will turn on the second conveyor in which boxes are present for a certain period of time, so that a next empty box will come ahead. For that period of time, the first conveyor should be stopped. Okay, as well as there is a count required also for these boxes. So not only we want to count the uh, jobs over here which are falling into box, but also we want to count number of boxes. So there are two set points required for the application. Not only a set point required for the number of jobs, which are 5, but also a set point is required for number of boxes that are being filled. Okay, to give an output, yes, the batch has been completed. So in this case, there is one preset value, that is first set point for the number of jobs, which is 5. Then there is a batch set point, which is 200, that will count the number of boxes over here. Okay, so let's see the same configuration how we can do in our demo counter. So if we look at our counter here, okay, this is the set point, which is 10. I'll change it as per our application now to 5. Okay, so these are the number of jobs which will fall into the box. And also there is an batch set point required. So you can press the BA button and here you can enter the set point for the batch. Say 200 will be more to simulate over here. I'll change this 200 to say 12 boxes is my set point right now. Okay, and I'll enter the MD key. So this is my preset value for the counter, number of jobs. 5 jobs needs to be put into the box, and my batch set point is 12. Okay, and this is the batch value which I'll reset here. Okay, to reset the batch value, you need to give pulse to the batch reset batch input. So this pulse you will find reset batch input in batch reset input over here. So for which we have connected an capacitive sensor. Okay, now if we look, the count value is 0. I am increasing the pulses 1, 2, 3, 4, 5. Okay, once the 5 jobs are put in, output is on for 5 seconds. One box is completed. If I increase the count again, second box is completed. If I increase it again, third box is completed. Fourth box is completed. So 4 boxes have been completed. Now if I go to the batch value, we can see 4 boxes are completed. Okay, and my set point is 12. So in the same way, let's say if I reach the 12 set point of batch value, so if we check the batch count value, it is right now 11. If I count one more batch, we can see 2 output turned on. So there is an actual output as well as the batch output. So the batch has been completed. So the batch has been completed. Okay, so if I want to reset this value now, I need to give a batch reset input. so that I can give through this capacitive sensor. So yeah, so once the sensor is triggered, we can see the batch counting value got resetted. Let's take a second example now. So the second example is with respect to the prescale value function that is available in counters. So using counters, we can also do cut to length application. So this function is with respect to the cut to length application, in which we need to put an scaling parameter. The number of pulses that we receive from the encoder, we can convert those pulses into an actual length measurement value. But for those we need to do some calculations first. Those calculations are explained in this presentation. So let's say, for example, there is a conveyor, and on this conveyor a paper sheet is moving, and we can see there is a cutter present, okay, which is going to cut the paper into particular length. Okay, but to do the proper length measurement, there is a pulley on which the paper is rotating, or the conveyor is rotating, and the same pulley shaft is directly mounted to this encoder. Okay, we can consider this encoder is same what we are using right now. So we need to do some calculations for those. Let's say, for example, diameter of pulley connected with the encoder is, say, 22 mm is the pulley diameter, and number of pulses for one rotation of the encoder in our case is not 1000, it is 360. So let's say in our case this value is 360. So we need to do calculation as below. Pi d, which is the circumference of this pulley. So in our case it is 3.1416 pi value into 22 mm, and number of pulses are 360. Okay, so this value will come up, will be 3.1416 into 22 divided by 360, 192 we can take. That means we will be receiving 0.192 mm per pulse. Means when a pulse is received from the encoder, that means 0.192 mm has gone ahead. Okay, so this value we need to put inside the SCL parameter. Once this is done, we will be able to count the length measurement. We would be able to do the length measurement. Let's see how this thing can be done in our counter demo. So let's see the same example in form of a demo here. Okay, so first what we need to do is we need to set our scaling factor to 0.191. Let's press MD key for some time, go inside configuration menu. So here we will also set the decimal point to 1 decimal place, so that we can see the value of length in mm in 1 decimal. Okay, and also let's set the scaling parameter to 0.191 as per our calculation. Let's come back to the online mode. Okay, and let me keep the set value over here to a high set point, otherwise we will not be able to see the length counting. Okay, so now we need to verify our exact length that is being checked over here. So we can see the shaft of the encoder. Okay, and I'm going to rotate the shaft to 360 degree, and we will check the length measurement. Okay, so we can see it is not right now counting for that 0 to 360. Okay, so exactly at 360 degree I will get the value 69.1. Okay, so what is this 69.1? It is nothing but the pi d was 22 mm multiplied by pi is 69.1 is the circumference. Okay, so so all the pulse values are directly converted into length measurement here. Okay, if I want to do a cut to length application, say to 100 mm, okay, I can directly put over here set point as 100. So okay, and for that, if you see now, once this 100 is being measured, okay, the output will be on, so through which we can activate the cutter, and then again it is ready for the second job of again measuring 100 mm length. Okay,